So I set up these circles, and I set up this to handle this mixture problem. But I have just done this with one variable. This is not a two-variable situation. I managed to do this with one variable. I guess the key was, I knew that was 5, I knew this was x, so the total was x plus 5. I could have acted like this was a variable. I could have called this y, I think. Then I would have, but it was real logical for me to do this. Anyway, now what? Maybe I feel like now you know exactly what to do, but maybe you don't. Here's what you got. You got this percentage times this amount, 0.18 times 5, plus this percentage times this amount, which is just a 1 times x, should equal this percentage times this amount. You're adding those two together to get this, 0.35 times x plus 5. And you have a nice equation to solve, and it's really just one equation with one variable. It's actually not two equations with two variables. And it's not that hard. But you needed a method, didn't you? I bet when you first read this, you didn't realize how easy it was, did you? You probably thought, holy shit, how am I going to do that? But a method helps, you know? Just, it's not that now. With a method, it's easy. It's very easy. You're mixing percentages. These mixing problems are usually amounts and percentages. So you put an amount and percentage. There are exceptions to how we set these up, though. I'll finish this one. What is 5 times 0.18? 0.9? 0.9 plus x. I'm going to distribute that 0.35x plus 1.65? 1.75. All right, I'm going to subtract the 0.35 from the 1x. That's 0.65x. I'm going to subtract the 0.9 over on the other side. That'll be a 0.85. Are you guys okay? I'm going to divide, and x is 0.85 divided by 0.65. You know, I made up these numbers here, so this may not be pretty, but this is the amount of gallons I need to do here. What is this? It ain't pretty, is it? What is it? 1 point something? 1.31.
1.307692.
307. All right. So it ain't a pretty number. Right. Okay. Thanks. That's what it is. So 1.31 is a decent idea of gallons. Cool. That was fun, huh, you guys? Next time you have a party, you can do something like this. Grape juice. Non-fermented grape juice. Cool. What if I would have tried to use two variables? I wonder what would have happened. I hope I don't. I might just make a fool of myself here. Let me see something. Pretend I didn't know that, and then I would say, what would I say? Yeah, that the amounts have to add up. That the x plus the 5 has to equal y. Right. The amounts, the two amounts that you're mixing together have to add up to the final amount. And then the other, that's one thing. And then when you multiply the percents times the amounts, they should add up to the percents times the amounts. So then I can write another equation, 1 times the x, are you with me? Plus 0.18 times the 5 equals the 0.35 times the y. So there I am with two equations and two variables. Yeah, that's kind of what they expected me to do, I think. But then watch what you do. What would you do now? I would definitely substitute. I would substitute this for this y. And as soon as you substitute this for this y, you have what we had, don't you? Right. So somehow I eliminated the variable in my setup. You know, I eliminated that second variable during my setup of the problem. That was pretty smart of me. I just called this x plus 5. It wasn't that smart, but it was pretty smart. Okay. Let's do another one. I'll read one from the book. I made that one up about the grape juice. Let's read one here from the book. A woman invests $52,000 in 2 different mutual funds. She's investing in the market. One averages a 10% per year. That's her interest that she's going to earn. And the other one averages 14% per year. If her average annual return on the 2 funds is $57.20, how much did she invest in each fund? Wow. All right, I might need to read that again. I wonder if my circles work on this problem. She's got 2 investments, and they're going to come to kind of one. One of her investments gives her 10% return. That's her interest she's going to earn. The other one is a 14% return. I don't even know the fund. Do they give me a final percentage? No. One of her investments earns 10% interest. The other investment earns 14% interest. In the end, I don't know what the percentage is, but in the end, her final, her interest that she earned is $57.20. So I don't have a percentage, but the amount she earned is $57.20. Now, what was the question? How much does she put in each fund? So let's call this one X. Let's call this one Y. And then the one thing I know about all her money is what? What do I know about X and Y? It totals. Well, the one thing I don't have written up here is that how much total money did she have? I read it at the beginning of the problem. She had $52,000. So her total money that she's splitting into these 2 funds is $52,000. What does that make me want to write down? Her total money. This is the money she's going to put in that one. This is the money she's going to put in that one. Her total money is $52,000 she's going to put in. What do I want to write?
X plus Y is 52,000.
Yes. So there's her total money. She's putting some of her $52,000 in there. She's putting some of her $52,000 in there. So there's one fact. All her money adds up to $52,000. That's a fact. That's a statement. That's a sentence. That's a equation with 2 variables. And then here's this fact, that when she takes this money and earns 10%, she's going to earn interest. The interest is the percent times the amount. The interest she earns is the percent times the amount. The interest she earns on this is the percent times the amount. And then what's the total interest she earned? $57.20. See, this is a little different. What did I need on this problem? I needed a percent and an amount, a percent and an amount, a percent and an amount. In these interest problems, it's not always like that. In these interest problems, I got a percent and an amount, a percent and an amount, but then I already have, this is the interest. So this is the final percent multiplied by the final amount already there. It's the interest she earned. This is simple interest, by the way. You put money in the bank and it earns 10% interest, you just get 10% times your money. Real simple. I'm not doing complicated interest formulas, okay? It's just 10% times my money is what I get. 14% times my money is what I get back. The question was, how much should she invest in each fund? So we've set this up as 2 equations, 2 unknowns. We've set it up. We took a word problem and wrote 2 equations, 2 variables. This might be the hard part of this chapter, translating these word problems into 2 equations, 2 variables. I don't know. I'm trying to help you with it. But anytime we do word problems, students tend to think they're a little difficult. What do you guys, how do you want to solve this one? Yeah, you could do that multiplying and adding thing. That's what she said, I think. I prefer to solve and substitute on this one. It depends. how you feel and what you want to do. You have some freedom to do whatever you want. But because it's so easy to solve for y, I mean, how do you solve for y up here?
Move the X over.
Move the x over. So what is y if you took this equation and solved for y, what is y? 52,000 minus x. Are you with me?
Mm-hmm.
And what should I do with that y?
Plug it into.
Substitute it in there. And now I'm home free. I feel like I'm home free. Here I go. I'm substituting that y in there. 52,000 minus x equals 5720. I'm going to distribute. I mean, this is, I feel like from here down, y'all can handle it, but I tend to help you anyway. Once you substitute it, you get 0.14 times 52,000. Oops. 7280. The 0.14 is also times that x, negative 0.14x. This is 5720. When you add those x's together, you get a little negative 0.04x. When you move the 7280 over, you get a little negative something over there. Negative 1560. How are you guys doing? Following me? Divide by this negative 0.04, divide by a negative 0.04, and x is, calculator sure helps, 39,000. So, I found x. And once I find x, I can find y. Where's y? You guys cool? If x is 39,000, y is right there, 13,000. Yes, ma'am?
Oh, wait, never mind. I just want. Sorry.
Okay. Cool. I think we got the answer. Everybody happy? 39,000. Plug it back in up there. Get y, 13,000. And so the answer is she should invest her money like this. She has 52,000 and she should split it up like this. She should put 13,000 in here and 39,000 in here. And what will she get? She'll get this much interest at the end of the year. What's funny about that is, if this is paying more interest, maybe she should put more money in there, you know? But maybe it's riskier, you know? Maybe she wants to be more conservative. Maybe that's risky investment. That's usually the case. So if it pays more interest, it might be a riskier investment, so she wants to put less in there. But either way, she's going to earn this interest with that split up. Let's do another kind of word problem. I'm done with that one. We answered it. Got to be careful. Remember how you answer these. I mean, the official answer is you invest 39,000 into the 10% mutual fund, and you invest 13,000 into the. I mean, it's almost like you've got to write a paragraph to answer it. But on my math lab, you get to choose your paragraph. There is this. This shows up in your homework, and I wanted to talk to you about this. Now, instead of using x, all of a sudden they use q. So I think they use q for quantity, which quantity is, you know, the amount, the number of units. So x, we've been using x for the number of units. All of a sudden they use q for quantity. On the y-axis, instead of y, I'm going to call it p, and it's the price. It's actually the price. And then if I draw a line like this, I'm not sure if that's called the supply equation or the demand equation. This is what we're talking about now, supply and demand of a product. Now let's think about this. This says the more items that are produced, the higher the price. That seems weird. Usually when you flood the market with a bunch of stuff, the price would go down. Oh, well, that would be the supply equation. I think this is the demand equation. Hang on. Yeah, that doesn't make sense either. Hang on. What'd you just, hang on. So now, the more people that want it, well, if people want it, yeah, if people are demanding it and wanting it, and then people want a bunch of this stuff, that drives the price up. The price is going up. Right, this is the demand equation. Everybody wants it, everybody wants it, everybody wants it, everybody wants it. You're selling millions of them, they're selling millions of them, that drives the price up in the demand equation. The supply equation is different. The supply equation has a negative slope. Why is that? That's different. That's me. I'm the supplier. Let me think about this. You got to kind of come at it from two different perspectives. You're either the public demanding it, or you're the supplier supplying it, I guess. Now listen. So now what? Hang on. Hang on. When the price is really, really high, there's not too many being demanded. There's not too many being sold. When I lower the price, I sell more of them. I sell more of them. I supply more of them to the market. When I lower the price, I'm supplying more of them. I'm the supplier. It's hard to get your head around this. That's the demand, that's the supply. The truth is, though, it's fun to talk about all the economics, sort of, and try to understand the economics. But the truth is, you see what's going on here. It's two linear equations, and what we're looking for is what's called the equilibrium price, or the market equilibrium. And that would be where the supply and the demand equal each other, which would be the point of intersection of these two lines, or the solution to the system of equations. I mean, we are in this context where we've been all day, solving two equations, two unknowns, solving two linear equations, two unknowns. So we are after this, which is what's called market equilibrium. And this would be the quantity demanded that produces the equilibrium price. And that's where supply and demand equal each other. And it's called market equilibrium. Okay, I didn't do too bad explaining this economics. See what happens after that? Hang on. So after that, if the price is too high, I got a lot of demand, but not enough supply. That doesn't make any sense. Anyway. Cool. So let me look at a problem. In the book, let's see what happens. A certain product has supply and demand functions given by this. Okay, you ready? P equals 5Q plus 20. P equals 5Q plus 20. And P equals 128 minus 4Q. You know what? I think I just screwed up. Hang on, let's just talk about this. Now, I hate to do this live on camera, but I think I screwed this up. Now, hang on. According to this, what I just read was this was supply and this was demand. Hold on a second. We might need to figure this out. Hold on a second. A certain product has supply and demand functions given by this, respectively. Supply and demand. Okay, well then stop a second. That means supply is the one with the positive slope. You see that? Positive 5Q. And demand is the one with the negative slope. Which is not what I just said a few minutes ago. Maybe that's why I had a hard time making sense out of this. But maybe, hang on. Does this make more sense? Supply is the one with the positive slope. And demand is the one with the negative slope. Maybe this makes more sense. Maybe I was screwed up. Maybe that's why it wasn't making sense. Hang on, let me think this out. So the more you sell, if you're the supplier, and you keep selling more and more and more, I think you're just going to keep jacking up your price. Yeah. When you sell more, more and more and more and more and more, you're going to just keep jacking up your price, I think. I don't know. What's going on here? If you're the demand, if you're the public demanding this, when it's a high price, you're not demanding much. Right? I'm trying to think about this. When it's a high price, you're not demanding very much. When you demand more, the price drops down. When you buy more, the price drops down. Maybe that makes more sense. And then there's still this equilibrium place. Maybe that makes more sense. Maybe I had it backwards originally. I'm sorry. We'll see what happens. Anyway, like I said, though, you can think all about that stuff and try to make sense of it, or ignore all that and do the math. It is just two equations, two unknowns, and you can do the math. Right. I would probably set these equal to each other. The way they're both solved for P, I would just solve them, set them equal to each other. 5Q plus 20 equals 128 minus 4Q. I would subtract the 20, that would be 108. You guys cool? Add the 4Q would be a 9Q. And divide by 9, and Q is 12. 12 is the quantity that gives you equilibrium, market equilibrium. 12 is the quantity. What is the price? Well, plug that 12 back in, and you can find the price. Either place, the price is 80. If you plug 12 times 5 plus 20, that's 80. If you plug 12 in here, that's 48. Subtracted from that's 80. Right, it's $80 is the price. That's good. That's all. That's it. Although it might be kind of, yeah, that's good. Okay, look. So I've helped you with some 2-3 word problems. There may be one or two other ones we might need to work with. But you can try those. They're in the homework. They just might show up on my tests and quizzes somehow. I want to take this last little 10 minutes and move into 2.4 here. So I'm switching into something else here. I'm moving into 2.4, which is what ends this chapter. And there's some real easy stuff here. I'm not sure how to make it a little more sophisticated or a little tougher, but here's what it is. It's just something we need to talk about. It's linear inequalities. Do you know what the word inequalities means? What we've been dealing with so far is equations. Equations have equal signs. Inequalities have less than, greater than, less than or equal to, greater than or equal to. You might even call not equal to an inequality. Everything that's not an equality or an equation is an inequality. So that's what we're dealing with, and so we have to solve inequalities like this. Here's an easy one. Can you solve this inequality? And when you solve an inequality, you treat it just like an equation, don't you? You do the same damn thing. You try to get x by itself. You move the 20 over, you divide by 7, and x is less than or equal to 4. When you solve equations, you tend to get one answer. You know, x is 4. Well, now I got more than one answer. I got x is less than or equal to 4. It's a whole bunch of damn answers. And what we tend to do is two things. There's the answer, but we like to maybe display it on a number line. So we draw a little number line. We put 4 here, and it's everything less than or equal to 4. And so it's everything less than or equal to 4. We shade the number line. At 4, we should color it in and include it. One way to do that is with a bracket. That includes it. So there's the answer. There's the answer. And maybe I want to write the answer in official interval notation, which we went over in chapter 1. This is an interval. This answer is an interval, and it's from negative infinity up to 4. Do you guys agree? You put a parenthesis on infinity, and you put a bracket on 4. So there's sort of 3 ways to display this answer at the end of this problem. And you can handle that. Now let's make it just a little tougher, okay? Let's make it a little tougher. You knew how to do this. You knew all this stuff. How can I make it a little tougher? Well, I like these. See this? I like that. That's called a compound inequality. It's kind of like 2 inequalities at once. What's going on is see this quantity here? This quantity is greater than negative 5. If you read it backwards, this quantity is greater than negative 5. But at the same time, this quantity is less than or equal to 6. It's a compound inequality. It's like kind of 2 inequalities at once. To solve it, what you really want to do is get x by itself, and you really want to leave x right there in the middle, actually. So you want to start getting rid of this stuff. You want to, like, I would multiply by 2. Would you multiply by 2? That's what I would do. But what's funny about this now is, you know how in algebra, whatever you do to one side, you do to the other side? What's funny about this guy is now you got 3 sides. So whatever you do to one side, you do to all 3 sides. I mean, it's weird to say 3 sides, but that's kind of how it is. There's 3 sides. When you say multiply by 2, you have to multiply this by 2, you have to multiply this by 2, and you have to multiply this by 2. You know, this is negative 10, and over here it's a 12. I want to point something out. Right here in the middle, the whole point of you multiplying by 2 was so you could cancel the 2. So please don't actually multiply it. You cancel the 2, that was your point, and you're left with 5x plus 8. I mean, I think you know that, but it's funny how I've seen people, they multiply by 2 and they kind of ruin the problem. Hey, what do you do now?
Subtract 8 from all sides.
Subtract 8 from all 3 sides. He's right. That leaves me a 5x in the middle. That's a 4 over there, and this is negative 18. One more move. Divide by 5, divide by 5, divide by 5. There's my answer. Negative 18/5 is less than x in the middle, which is less than or equal to the 4/5. I mean, when you write this, you can read it accurately. What I see is very clearly x is between those 2 numbers. I mean, to me, that's what it says. X, and it looks like it's between those 2 numbers. It's less than or equal to that number, but at the same time, it's greater than that number. On a number line, you can display this. You can put a 4/5 right there. You can come down here and put a negative 18/5 and shade everything in between. Do you want to include the 4/5? Do you?
Yes.
Then let's put a bracket on it. Do you want to include the 18/5? No, we'll put a parenthesis on it. I could also do my official interval notation the same way. Negative 18/5, comma 4/5, parenthesis and bracket. There is one more thing to say. I'm going to let you go here. I'm not going to do an example, but one more thing to say about inequalities, and I bet you know it. So you solve them just like equations. And there is one little added rule with inequalities. If you ever multiply or divide by a negative number, in the process of doing this, if you ever multiply or divide by a negative number, switch the inequality symbols. If they're less thans, turn them to greater thans. If they're greater, switch the inequality symbols if you divide or multiply by a negative number. All right, let's quit today. I'll see you Thursday.